Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals More Examples. In this presentation, we will be solving example problems related to trinomial functions and radical functions. So let us look at an example. We want to evaluate an indefinite integral x cubed minus 4x plus 2 dx. So this looks like a trinomial function, right? So what we're going to do is we're going to integrate each one of these terms separately as shown here. Integral x cubed dx minus integral 4x dx plus integral 2 dx. Since we have some constants inside these terms, we're going to take them outside of the integration process so we can integrate just the function by itself. So the first one we can write as, if we have x cubed, it means 1x cubed, so we can pull out the 1 outside of the integration process. 1 integral x cubed dx. If we don't write the 1, it doesn't matter. 1s are implied in math. So 1 integral x cubed dx minus, we have 4 integral 4x dx. 4 is a constant, so we're going to take 4 outside of the integration process. Integral x dx plus 2 is a constant in this third term, so we're going to pull out the 2 outside. So 2 integral dx. We're going to now integrate each one of these functions separately, and when we do that, this is the way we're going to write it out. So 1 is a constant, so we're going to put that on the side, and then integral x cubed dx we can write as x to the power of 3 plus 1 divided by 3 plus 1 minus the second term 4 integral x dx we can write as 4 times integral x dx can be written as x to the power of 1 plus 1 divided by 1 plus 1 plus 2 integral dx. 2 is a constant, so integral dx converts to just x plus c is a constant of integration. Whenever we complete the process of integration, we're going to add a constant to the end of the process. So when we simplify this, it's going to convert as follows. 1 times, we're not going to write the 1 anymore, it's implied. So x to the power of 3 plus 1 converts to x to the power of 4. And in the denominator, we have 3 plus 1, and that converts to 4 minus 4 times x to the power of 1 plus 1 converts to x to the power of 2. And in the denominator, we have 1 plus 1, which is equal to 2, plus 2x plus c. So when we simplify it some more, this converts to x to the power of 4 divided by 4 minus, we have a 4 on the side, we have a 2 in the denominator, so we can simplify that to 2x squared plus 2x plus c. X to the power of 4 divided by 4 minus 2x squared plus 2x plus c is our solution, where c is a constant of integration. So this is the way we want to be able to solve an example problem which involves a trinomial function as shown here. Let's look at another example. In this example, we have some radical terms. So let's evaluate this indefinite integral. Integral cube root of x minus 1 over 2 times the cube root of x dx. So to be able to simplify this, we want to, first of all, to be able to solve this example problem, we want to convert the radical terms to exponential terms. And how do we do that? This is the way we want to do it. Cube root of x we can write as, cube root of x is a radical term, and we can write it as an exponent as x to the power of 1 over 3. Those are some of the rules of converting the radical terms to exponential terms. So once we have that, we can write the given function as y is equal to integral x to the power of 1 over 3. We converted cube root of x as x to the power of 1 over 3 dx minus integral 1 over 2 times x to the power of 1 over 3. We converted cube root of x as x to the power of 1 over 3 dx. Now, we're going to now see if there are any constant terms so we can pull them out of the integration process. In the first term, we don't have any constant, so we're going to write it as is. Y is equal to integral x to the power of 1 over 3 dx minus, in the second term, we have 1/2 as a constant. So we're going to pull out that 1/2 outside of the integration process, um, as shown here, times integral x to the power of negative 1 over 3 dx. So when we have, uh, this was actually 1 over x to the power of 1 over 3. So when we bring an exponent which has a positive power to the numerator, that converts to a negative power. So we can write it as x to the power of negative 1 over 3 dx. So now we are ready to apply the integration process. So when we do that, we can write it out as follows. Integral x to the power of 1 over 3 dx can be written as x to the power of 1 over 3 plus 1 divided by 1 over 3 plus 1 minus 1/2 x to the power of negative 1 over 3 plus 1 divided by negative 1 over 3 plus 1 plus c is a constant of integration. So when we simplify this some more, we have x to the power of 1 over 3 plus 1 simplifies to 4 over 3, right? And then in the denominator, we have 1 over 3 plus 1, which converts to 4 over 3, minus 1/2 x to the power of minus 1 over 3 plus 1. When we simplify that, that simplifies to x to the power of 2 over 3. And in the denominator, we have negative 1 over 3 plus 1, that converts to 2 over 3. And we're going to always add this constant of integration plus c as shown here. When we simplify this some more, in the denominator, we have 4 over 3, and when we bring it to the side of the expression, that converts to 3 over 4, x to the power of 4 over 3, that is the first term, minus, we have 1/2 on the side, we have 2/3 in the denominator, and when we bring it to the side of the expression, that converts to 3 over 2, so we have a 3 in the numerator, and then 2 times 2 in the denominator, which converts to 4. So 3 over 4, in the numerator we have x to the power of 2 over 3, and that's what we have written here, plus c. So this is our answer, 3 over 4 x to the power of 4 over 3 minus 3 over 4 x to the power of 2 over 3 plus c, where c is a constant of integration. This is the way we're going to solve example problems involving radical terms. So in my next video presentation, we will be solving more examples involving indefinite integrals.